Let's try problem number 2. Zero point 0.0036. We'll add that to 0.64. 6 and nothing is 6. 3 and nothing is 3. 0 and 4 is 4. 0 and 6 is 6. Decimal point and then a 0. Right. However, do we leave the answer in this form, 0.6436? Do we need all these digits? Well, for addition and subtraction, the rule says go back up to the numbers that you were adding together and locate the position of the last sig dig in each number. This first number, 0.0036, there are only 2 sig digs. The leading zeros are not significant. The significant digits in this first number are the 3 and the 6. And the last of those digits, the 6, is in the 4th decimal place. Right, what place value is the 4th decimal place? Well, this is tenths, hundreds, thousands, 10,000ths. So it's the 10,000ths place. Right, is the 6. All right, let's take a look at the second number that we added together. 0.64. How many sig digs there? 2. All right, these leading zeros are not significant. All right, so the 6 and the 4 are significant. The last of these digits, the 4, all right, is the number we want to be looking for. Actually, what we want to really do is not look at the number 4, but its position in the number. What place value is the 4? Well, this is tenths and this is hundreds. 1/100th place. We need to choose out of here which one of these two is of greater value. Is it 10,000ths place greater or lesser in value than the hundredths place? Now, the simplest way to remember this is just to choose the place that is furthest to the left, because as you go to the left, you go to higher place values. All right, so it's going to be this guy right here. All right. We want our answer, 0.6436, rounded to the hundredth place, which means that we are going to have to get rid of the 3 and the 6 here. And so maybe we draw a little line through here. We want to get rid of that. All right, 0.64. All right, do we round the 4 up to a 5? Well, no, because the number just after it, 3, that's less than 5, so we round down. So here's our answer, 0.64. Try another problem. In this case, we're going to jump up to problem number 5. 497, and we're going to add that to 0.34. Again, when we write this addition problem in column form, one number over the other, we want to line up the decimal points. The decimal point in this first number is located after the 7. Right? It's not actually written there, but we know it's there. Okay, so let's go ahead and do this addition. We just bring the 4 down here. We're going to bring the 3 down here. Decimal point, 7 and 0 is 7. 9 gets brought down, and the 4 gets brought down. 497.34 is what we would get if we were to do this on a calculator. That's what our calculator would tell us. But is that the correct answer? And no is the answer to that question. We can't write all of these digits. And if we go back to some of what I wrote down yesterday on these notes, the answer to a mathematical problem can be no more accurate than the least accurate piece of data used to compute it. We know this first number, whatever it is, 497 kilograms of mass, let's say. We know that measurement to the nearest 1 kilogram, right? If we used the more sensitive balance, maybe we would have measured it to be 496.9 grams, for example. But whatever balance we used only measured to the nearest 1 kilogram, right? Let's say this other mass, the 0.34, was measured on a much more sensitive balance. We knew down to the hundredths of a gram that it was 0.34. Right? It wasn't just 0.3. it was 0.34 grams. So we really have much more accuracy in this second number than we do in the first. Right? When we add these two together, our answer can be no more accurate than the number up here, which is least accurate. Now we determine that by looking at the location of the last sig dig. Right? This first number, 497, the last sig dig is a 7. It's in the ones place. And as I said, we knew the mass up here to the nearest 1 kilogram. The second mass here, we knew to the nearest hundredth. Right? The 4 is in the hundredths place. We knew that 0.34 grams or kilograms. We knew that mass to the nearest hundredth of a kilogram. When we add them together, can we be certain or correct in saying that we know the total mass is 497.34 kilograms? Well, no, we cannot. Since this measurement was only as precise as the nearest 1 kilogram, our answer can only be as precise as to the nearest 1 kilogram, which means that this 3/4 has to be cut. All right? We want to leave our answer to the ones place. Right? And that goes exactly back to this rule here. The answer to an addition or subtraction problem, this number right here, this answer, will have its last sig dig in the same place value location, right? In this case, the ones place, as that number whose last sig dig is in the highest place values that we use to come up with this. These are the two numbers we use to come up with this answer. We have to analyze these two. We have to analyze the position of its last sig dig. This is in the ones place. This is in the hundredth place. Which one of these is the higher place value? Well, it's this one, the ones place. So we have to mirror that down in our answer. Our answer has to be rounded to the ones place. So we will get an answer of 497. All right, we're cutting off the 3 and the 4. The 3, however, is less than 5, so we round down or leave it the same. So there you go. Our answer would be 497 kilograms if we were attaching units to it.